All right. So in order to find the average rate of change, we need to find the y values of the function. So the first thing I'm going to do in the problem, it says I'm going from x is -2. So I have a point, -2, and the other point is -1. So this tiny little interval, I'm going to find the average rate of change. And I know that my function is -x³ plus 3x. So I'm going to find my y values and then calculate the slope. Okay, easy. So let's put in -2. So -2 would be -2³ plus 3 times -2. Okay, so what is that? Two? What do you think, class? Is he right? A lot of negatives floating around. So we put in -2, we get 2. Now we put in -1. And we get -2. You all right with that? All right. So now we're just going to find the slope. The average rate of change is just going to be the slope. So I'm going to say average rate of change. So I get familiar, comfortable with that vocabulary. And what am I going to do? I'm going to do what I always do. So I'm going to take my y minus my y over my x minus my x. So these are your y's, these are your function values, and these are your x values, right, that were given in the interval. So what do you come up with? -4 over 1. Did you just get -4? So if you look at the picture, oh wait, no, that's not the right picture. I don't have a picture for this one. What is it, if the slope's -4, what does that tell me about the relationship between these 2 points? It's decreasing, right? It's going down. All right, do B by yourself. Same thing, different function, different interval, but do B. I'm glad this happened. I want to talk about this. Are these the values you got, your y values? Okay, let's talk about this for a second. Let's suppose we can't use a calculator. How do you think we might go about simplifying that without a calculator? Josie? So what would the common denominator be? 14. Now, what you and I might have different ways of doing the problem, but what I like to do is multiply the whole shebang by 14. Because what that does is eliminate the denominators. So I end up with 7 minus 4 over 42, which is 3 over 42, which is 1/14. So the average rate of change is 1/14. Now, do I care how you do it? No, as long as you're coming up with 1/14 without your calculator, we're all good. Okay? Now, any question about that? All right, let's get our calculators out. Let's do it on our calculators. Pretending that the directions said answer exactly. All right? Because here's what happens. If you put in 1/2 minus, I don't even know what was it, 2/7 equals, and then divide by 3, don't you get some kind of crazy decimal? Yep, and I don't want to don't round it off. I want the exact answer. So if I press my math button, very first option is frac, hit enter, and it will come up with 1/14. So to get your decimal back to a fraction, don't know if you noticed already, you hit math, frac. And that will change it right back into it for you. So even if you're allowed to use a calculator, that will be the exact answer. Okay, let's see what's next here. The graph is shown. Find the average rate of change over the interval from -1 to 3. Okay, so the average rate of change, I'm just going to abbreviate instead of keep writing that, is going to be f of 3 minus f of -1 all over 3 minus -1. How are we going to find f of 3 when we don't have a function rule to do it? We have our picture, right? So what's f of 3? 4. What's f of -1? 0 over 4. So it looks like my average rate of change is 1. Now, keep in mind, guys, okay, so this is the slope of the line that joins those 2 points. The slope of the curve itself is constantly changing. Would you agree with me on that? So we're going to do this one problem at the bottom. Then we're going to look at how we can find the slope of the curve itself. But first, table 3 above, find the average rate of change of females born from 1850 to 2000. Go ahead, do it. Got everything you need right there. You can use your calculator because these numbers are kind of yucky, but you got it. Everything you need is right there. Okay, you coming up with 0.2382? No?
Yeah.
Yeah? Now put a unit on it. What is that? That's 0.2382 watts. It's a rate of change. So it's just like speed. Speed is miles per hour. What is this? Something per something. I heard somebody say something, but I couldn't hear. Age years per birth year. So it's kind of weird to say that, but that's what it is. It's age years per birth year. Can't really say years because there's kind of years going on. But remember, this is a fraction. And when you computed the fraction, the y's were on top. And what are the y's? Age. So it's age per birth year. what does that mean? Every year since 1850, people have lived 0.23 years longer, right? Perfect. All right, turn it over. The idea of instantaneous velocity or instantaneous rate of change is equivalent to finding the rate of change of a function at a given point. So basically what we're talking about is, okay, so we have some kind of funky curve, and I want to know the slope of that line right there. That would be the slope at that point. Without calculus, that's kind of impossible to do, because to find slope, you need 2 points, right? So think about what would happen. Obviously, back to my picture, if I picked a point here and a point here, then that would give me that slope, right? But what if I picked 2 points that were closer together? Would that slope be closer to the slope of the line I want? This is the line I want, this tangent thing here. So the moral of the story is, the closer together you can get those points, the closer to the instantaneous rate of change you'll have. Would you agree? So here we go, it's up there at the top. We can approximate the rate of change at a point by using the average rate of change over small intervals. The smaller, the better. So you keep squeezing in on that, getting smaller and smaller. You watch what your slopes are, and then hopefully you can make a conclusion about what your slope at a given point is. All right, so let's see what's going on. A ball is thrown vertically in the air, the height of the ball, okay. Find the average rate of change and the height of the ball over the given intervals. All right, would you and your partner, keep in mind, this is your function. By the way, this looks a little bit different than the one we did a few days ago. The one we did a few days ago had a -16 here, because that one was in feet. This height is going to be measured in meters. Okay, so if you're in meters, it's always going to be -4.9. If you're in feet, it's always going to be -16. Same formula. Initial velocity, initial height, same formula. All right, so we're going to measure it over the interval from 1 to 1.1. So you do just what you just did. You're going to find h of 1.1, subtract h of 1, and divide it by 1.1 minus 1. Okay, go ahead and do that. And when you're done, do the next 3. Do them all. And then see if you can figure out what the rate of change at 1 will be. Is all three done? What are you doing? Thinking? Okay, you're gonna do this, you're gonna do that calculation. Figure out what that function is. You're gonna symbol here. H of this minus H of that. So those two subtract, same thing here, same thing here. And then, you're gonna make a conclusion about what the instantaneous rate of change at one is. In other words, that parabola you graphed, what is the slope of the parabola at one? That's what you're looking for. What'd you get for the first one? You don't. I mean, guys, when we say h of 1.1, that means you go back to your equation and you put 1.1 in for the t. You're finding the function value at 1.1. So this means you have to find the function value at 1.1, then you have to find the function value at 1, then you subtract them and divide. So was that 1.1? Okay, so now you're gonna find 1, same thing, and 1. So this is like f of x, and it's h of t, so you're plugging in your t value and finding the h that goes with that. Keep in mind, once you found h of 1, you don't have to keep recalculating. What'd you get? 14.71. Patrick got 14.71. Anybody else get that for the first one? Okay. By the way, what's the unit on that 14.71? Meters per second, absolutely. Height over time, that's your speed, meters per second. Anybody get the second one yet? Raina?
15151. Oh.
Okay, so can you give that to me decimally? 15151. Is it
I got 0.1.
15.151? Alright, I guess I can live with that, okay. 15.151,
Meters.
okay, meters per second. Alright. I know the exercise is redundant because you're basically doing the same thing 4 times, but remember what your goal is. The goal is to figure out, okay, I know how fast the ball is moving on that interval, and this interval, and this interval. How fast is it moving at that point? What is its velocity, its rate of change at t equals 1? That's what we're trying to figure out. Did you get those numbers or did you just copy mine?
No, I got
You got that, good. What did we get here? Anybody got this one yet, the third one yet?
15.1951.
15.1951, that's interesting. Okay. Now, did you notice that these intervals were from 1 to something a little bit bigger than 1? But this last one is from going the other direction, a little bit less than 1 to 1. Anybody got that one?
It's a negative.
Oh, no, not negative. Is it?
No.
Shouldn't be negative. 15.2049. Okay. So this was the interval 1 to 1.001. And this was the interval 0.999. All right, I'm waiting. Does anybody have a thought about what the instantaneous velocity at t equals 1, at time 1, what that might be? 15.2, Mr. Kirsch. How awesome is that? Now, tell us how you knew that, and that would be meters per second. So tell us how you knew that.
I just kind of added two numbers, and I knew that since it wouldn't be, it's the 0.99 and then the 0.1, with the B in between those, and 2.
See, my 15.2 is a good answer, yeah. And that's very, very good. So here's the deal. This one is just a little bit under 15.2, and this one's a little bit more than 15.2. The point we're looking for, 1, is kind of in the middle of those two because this one went to 1.001 and 0.999. So his logic is perfect. Very good, Mr. Kirsch. Amazing. Okay. For each scenario below, determine whether the two quantities have a positive rate of change or a negative rate of change. The child's height, or excuse me, child's age and the child's height. Do you think if you had a bunch of data for kids and you plotted all those points, do you think your slope would be positive or negative? Positive. The older the kid gets, the taller he gets, right? Under normal circumstances.
Wait, so with the 15.2, that would be, what would be in the denominator? Like, for instance, what were you trying to say about that?
Okay, well, first of all, you can't find the slope at a single point because your denominator would be 1 minus 1, which is 0. You can't do it.
Yeah.
So think about this interval and this interval, okay? So I'll just look, so here's 1. This one is right over here. We're talking about this interval right here. And then the other one is right over here. We're talking about that interval right there.
Yeah.
This one is a little bit more than 15.2. That one's a little bit less than 15.2.
Yeah.
So it seems like at the point that's in the middle, it will be 15.2. Okay?
Yeah.
All right. All right, how about a goal for skill and a goal for score? Negative. Because the higher your skill level, the lower your score. The height from the ground. The height from the ground of a coin dropped off, I don't even know what that is. It's the tallest building in the world. Thank you for enlightening me. And the speed of a coin. The height from the ground. So think about it. The closer it gets to the ground,
Faster it goes.
the faster it's going to be going. So as the height becomes less, the speed becomes more, so wouldn't that be negative? Yeah. All right, next page. This first side is all about kind of just normal thinking, explaining. All right, so food industry is made up of a bunch of businesses. Okay. How do these businesses decide which items to advertise and how much to charge for each product? What types of food or drink do you see advertised most often?
Coke.
So Coca-Cola. Okay, what else? Gatorade. What else? Body Armor. What is Body Armor? A drink, okay. So we're all talking about drinks here, a lot of different kinds of drinks are advertised. What do you never see advertised? Huh? Talking about like food items, apples, milk, bread. Why not? Why do we see Body Armor advertised, but we don't see eggs advertised? You need eggs, but I mean, I'm not saying you have to have eggs to survive, but eggs, like if your mom goes to the store, your dad goes to the store, normally they pick up some eggs and bread and milk, right? Those are like the normal grocery items. What do they not pick up? Obviously, I don't pick up Body Armor because I didn't even know what it was, right? Those are more optional food items, maybe, right? So when we look at this graph, we're modeling soft drinks and formula. What do you notice about the two graphs? Now keep in mind what's the grid there? X values are the price and Y values are the number of customers. So what happens to soft drinks as the price goes up? A lot less people, right? That's very steep. We're losing a lot of people. But what about formula? We're losing, but
Slower.
not as fast. Why would that be? Why potentially could that be? You need formula, right? Baby's gotta have that. So they might buy less, which is very sad. But pop you don't have to have, right? Soda you don't have to have. Soda gets too expensive, just quit buying it. Which customer base, formula or soft drinks, is more swayed by an increase in price? We already talked about that. That's the Coke people. We know that because the graph is steeper. Look at the data, calculate the company's revenue. All right, go ahead, do that. Calculate the revenue of soft drinks. Actually, you don't really need to calculate. If the price is $10, how many soft drinks? 200 million. And so then what would my revenue be? 200 million times 10, which is what? 2 billion? And at 45, you'll have to do that math for me. What is it at $45 for Coke? $1,350,000,000. All right, what about formula? $10 formula is going to be, approximate it, about 780 million or roughly that. And how about 52 million? What'd you get for that one? I got 2 billion and some. Do you think it's a good idea for companies to always charge more? No, obviously what's gonna happen? People are gonna quit buying it. If they don't buy it, you don't make any money at all. So that's what the next graph is about. This graph is about the revenue for baby formula. X is the price, Y is the revenue in millions. Does each equal increase in price change the revenue by a constant amount? I don't want you to do any math. I I want you to look at the picture and tell me, if I increase X by the same amount, is Y gonna grow by the same amount? In other words, is the average rate of change constant? No. What kind of picture has an average rate of change that's constant? A line. A line. This is not a line. So there's no way that the equal increase in price is gonna equal, or make the revenue a constant amount. All right, so a new guy at the company suggests selling the formula for $20. Is this the best price? Remember, X is the price. So is selling the formula for $20 the best thing they could do for the company?
No,
Why?
because if they sell it for $62,
Bingo. We wanna make more money, right, if we're the company? So clearly, $20 is not the highest revenue. Where does the highest revenue happen? About 60? Yeah, we can argue that, but it's in the 60 area, right? So 80 is not the best price. The goal is to make the most money, so that would be about 60. At what price will the company make no money?
0 and
Yeah, 116, I'll take that. Okay, so what happens at 0? If you choose to sell your formula for $0, you'll probably sell a lot of it, but you won't make any money. And if you choose to sell it for $116, no one is going to buy it, so you won't make any money. Okay. When or why might companies use factors besides revenue to determine their prices? I mean, businesses want to make money, but would there ever be a situation, do you think, where that wouldn't be the driving force? Oh, you guys should know this, you lived through the pandemic. Didn't companies take losses on things in order to supply what the people needed? We just went through a huge baby formula shortage, and companies were selling that at below their cost because kids were going to die if they didn't get it. So you budding business people, remember you have to have a heart too, right? It's not always about the dollar. All right, quick notes. Quick notes. Here we go, we're almost done. Quick notes. A graph can show what? What does a graph show me? What's one of the things a graph can show me? Exactly. How two quantities relate to each other. So you just looked at a curve that showed how the price of the formula and the revenue were related. So a graph can show us the relationship between two quantities. That's exactly right. Good. We talked about this from yesterday. I'm not sure why it's in here again, but an increasing function, define it. Don't say it goes up. How do we define an increasing function? If A is greater than B, then F of A is greater than F of B. You know this. If A is greater than B, then F of A is bigger than F of B. Now you can also do the less thans, but the point is, as X gets bigger, as input gets bigger, then output gets bigger. Isn't that what makes you increasing? So what's decreasing? If A is greater than B, then F of A is less than F of B. These are your inputs, these are your X's. So if my X's are growing, then my Y's are shrinking. That's decreasing, right? What's the matter?
No,
Go ahead, what?
it's the same thing. Like if A is greater than B, then F of A is greater than F of B, and F, it's the same.
I wrote the same thing twice?
Well,
You have
no.
F.
On the first
If
floor.
the
A is
first
greater
half.
than
Oh,
B.
no, I want the same thing there.
Okay.
So as my X's increase,
Yeah.
okay, in both cases, my X's are increasing.
Yeah.
If it's an increasing function, then my y's will also be increasing. If it's a decreasing function, then my y's will be decreasing. So x is getting big. In both cases, I'm letting x get big. If y also gets big, you're increasing. If y gets small, you are decreasing. Okay, is that registering? I need that to register. That's kind of a big idea, right? Okay. All right, number 1 and 2, do it with your partner. 2 is kind of a review problem like we did yesterday. But do 1 and 2. See if you can interpret the graph. I need to take attendance and check.
Yeah, and it's the second
Wait, I got about 15. A little over 15. Because the grocery store and all the way at the top. So about 40 to 55.
walked it. This is him at the bank.
And then that's going to be the grocery store.
So what if, oh, and him walking.
No, how long is he at the grocery store?
But right here, she's
Also,
walking.
Yeah. He's there.
Tomorrow starts, I think, homecoming dress up days tomorrow. Pretty sure.
Oh, yes.
I'll put you on the Stuco Instagram video.
Alright, let's go. How are we coming along here? We're about out of time. We gotta get through this.
We're just in question 1.
I am too. How long did the trip take him? 75 minutes. Let's get in the habit of putting units on things. How many minutes is he at the grocery store? Yep, 15 minutes. On which time intervals are we decreasing? 55 when he left the grocery store till 75. Yep. What does that mean in the context of the problem? He's coming home. His distance from home is decreasing. So he is walking home. Walking home. Good. At which time is he exactly 1 mile from his home? 12 and what is that, 60? Oh, wait, 67-ish? Okay. All right, let's get a picture of number 2 up here. You got a picture drawn? We practiced these yesterday, but they were a little bit more intense than this one yesterday. Who's got a picture? You got one? Let's see it, Brady. If it's right, we'll clap for you. How's that? Oh, I forgot our third note too, I gotta put that in. We'll put that in. I'll look at this picture.
Is it?
Yes.
I think I.
I've noticed
You're
that.
good, you're
I've
good.
noticed that all class in the first like 68. I noticed in meeting class, I chose not to say anything.
I walk around one day with my shirt inside.
I think it's better this way either
I
way.
think it's right inside. Okay, what do you think about that picture, guys? Are you good with that? It says we're decreasing from -5 to 0, and I love how we labeled this x-axis, and then we're increasing from 0 to 2, and then constant for bigger than 2. That looks absolutely great. Great. Okay, back up to your notes. Let's put notes up at the top. What are some important points that tell us information about our picture? Think back to this graph of the baby formula and revenue. What were the important points on there that we kind of used to figure out like some key things? Josie?
Like intercepts?
The intercepts, hugely important. What did the intercepts tell us, the x-intercepts in this problem? They told us where we made no money, right, which is not what we want as a business. What else is important in there? The maximum, so we call that the maximum. Sometimes the minimum would be the important point, depending on the context of the problem. What else is kind of important? Maybe not so much in this one, although maybe the whole idea of whether the curve is increasing or decreasing. So increasing intervals and decreasing intervals are important to know. If it's increasing, we know that our revenue is going up, and that's a positive thing. If it's decreasing, our revenue is coming down, and that would not be such a good thing. Good. All right. There was one more question I guess. Oh, so that those are important things to look at. Look at max and min. Look at intercepts. Look at decreasing, increasing. Those are going to be focus points for us. Can you think of a type of problem where it would be the minimum point that would be important to us? Think back to our box problem. Remember the box problem where we made a box? That problem was all about maximizing the volume, okay? But what if I'm actually building the box, like I have to construct the box? Wouldn't I want to minimize the surface area? Because the smaller the surface area, the less material it takes to build it. So that would be an example of where I would want a minimum point. If it's the minimal value that's important to me, that I would need a minimum, okay? All right, all good stuff. 1.2 is due on Monday, Tuesday. 1.2 is due on Tuesday. And 1.1 is due tomorrow.
I had to wait.